class 12 atoms. Here today I am going to give the summary about atoms. It was Rutherford who proposed the atomic model, that is nucleus are positively charged, which is at the center, and the electron revolve around the nucleus, same like the planetary motion. He gave the idea of an atom, structure of an atom. Now here comes the classical electromagnetic theory. This is the classical electromagnetic theory. According to classical electromagnetic theory, a revolving electron radiates, revolving, that is an accelerating electron, and revolving, or you can say an accelerating electron, radiates energy, emits radiation. It will be better to say that an accelerating electron emits radiation, that is electromagnetic wave, and accelerating electrons emits radiation, that is electromagnetic wave. So as per the model proposed by the Rutherford, the revolving electron will radiate light, that means electromagnetic wave, and it will, instead of a circular path, it will form a spiral path and it will fall on the nucleus. So this was a drawback, and another is that since the electron is changing its angular velocity, since the electron is changing its angular velocity as well as frequency, in electromagnetic radiation, in a classical electromagnetic theory, it is also said that the frequency of the revolution of the electron, that is the frequency of the revolution of the electron, that is the frequency of the revolution of an electron is the frequency of the electromagnetic wave. So when the electron is in the spiral motion, that means the angular speed and the frequency of the electron is changing. The angular velocity and the frequency of the revolution is changing, the angular velocity and the frequency of the revolution is changing, so we must get continuous spectrum. But practically we get line spectrum. So these were the drawbacks. Now Rutherford, he thought that if we try to explain the model of an atom with the help of the classical electromagnetic theory, it will be impossible to find out the structure of an atom. So he made three postulates. First was the stationary. First was that there were fixed orbits used. That means stationary orbit. He considered stationary orbits when the electron is revolving in the stationary orbit, it does not liberate any energy. First he considered fixed orbit, that is the stationary orbit, and the electrons revolving in this orbit, it does not radiate any energy. And second postulate was that what will be the orbits of an atom. So he said that the angular momentum is an integral multiple of h by 2 pi, where h is the Planck's constant. Only those orbits were permissible where the angular momentum of the electron is an integral multiple of h by 2 pi, where h is the Planck's constant. So only those orbits were permissible where the angular momentum of an electron is an integral multiple of h by 2 pi. Only those orbits were permissible. And third, he said that if there is a transition from one orbit to another orbit, if there is a transition, that means if the electron moves from a higher orbit, from a higher energy level, from a higher orbit to a lower energy level or to a lower orbit, it emits a photon. It emits a photon, and the energy of the photon will be equal to Ei minus Ef if there is any transition. That means if an electron moves from a higher energy level to a lower energy level, or from a higher orbit to a lower orbit, it emits a photon, and the energy of the photon is equal to Ei minus Hf. These were the three important postulates given by the Bose. He shifted it from the classical electromagnetic theory. Now came Louis de Broglie. According to Louis de Broglie, that is, any matters have particle nature and wave nature. So the electrons also have particle nature as well as the wave nature. So he argued that the orbits, according to the Bose, the orbits these orbits must have particle waves. These orbits must have particle waves. Particles waves. So Louis de Broglie, he argued that these orbits, according to Bose, must have particle waves, and these particle waves must be stationary waves. Stationary waves. They must be stationary waves. So, an electron in an rth, so an electron in whose radius is Rn, means nth orbit, whose radius is Rn, that is nth orbit. So the circumference of that electron, 2 pi Rn, is equal to integral multiple of wavelength. So de Broglie said that these orbits must have particle waves, and these particle waves are stationary waves. So he considered an nth orbit of an electron, and the circumference of the nth orbit is equal to integral multiple of wavelength. So according to de Broglie, lambda is equal to h by p, which relates the particle nature and the wave nature. Here p is the momentum and lambda is the de Broglie wavelength. This is the de Broglie wavelength and p is the momentum. So here 2 pi Rn, that is equal to n h by p. So momentum here, the velocity of the electron, we considered that is p is equal to mvn, where this velocity of the electron is less than the velocity of the light. So here 2 pi Rn, that is equal to n h by mvn. So mvn Rn is equal to nh by 2 pi. So here this is the angular momentum of the electron, and it is the integral multiple of h by 2 pi. This de Broglie proved the Bose's second postulate. So this is all about the main points in your chapter atoms, and this is applicable only to the hydrogen atom. This is applicable only to the hydrogen atom. Thank you.